In many flexible PU foam factories, catalysts are often discussed as if they were one single category, with differences reduced to brand, dosage, or whether they act a little faster or slower. In this episode, we focus on one key question: why amine catalysts and tin catalysts are fundamentally not doing the same job. In flexible PU foam production, amine catalysts and tin catalysts are not a matter of which one is stronger or which one works better. Their real difference lies in where they intervene in the reaction process. Let's start with amine catalysts. Amine catalysts are more involved in reaction pathways related to foaming, specifically the reaction between isocyanate and water that generates gas. As a result, amine catalysts mainly influence when the foam starts to rise, how fast it rises, and how concentrated the gas generation is. In other words, amines are primarily controlling the rhythm of foam expansion. Now let's look at tin catalysts. Tin catalysts are more directly involved in polymerization and structure formation. In other words, when the foam skeleton is built and when strength starts to develop. They are not concerned with whether the foam can rise first. What they care about is whether the foam can support itself after it has risen. So what tin catalysts truly control is when the foam begins to set, and when it transitions from a flowing system into a structured material. This is the critical difference. Amines control whether the foam rises and how it rises. Tin catalysts control whether the foam holds and when it holds. Because of this division of roles, you will observe some very typical phenomena in real production. If amine levels are high but tin activity cannot keep up, the foam may look very aggressive at the beginning, but later becomes weak and prone to collapse. If tin levels are high but amine activity is insufficient, the foam tends to feel stiff, struggles to rise, and the target density becomes difficult to achieve. This is not an operating mistake. It happens because the two types of catalysts are not acting on the same reaction pathways. But the issue does not stop at different roles. When amine and tin catalysts are present at the same time, they are not simply working independently. The truly complex, and most easily overlooked, part is that they can amplify each other's effects, or cancel each other out.